Hello everyone and welcome to this presentation about the study and conservation treatment of Psicoplastica nel campo 400 by Franco Grignani. In the first part of this presentation I will talk about the description of the artwork and the technical analysis that we carried out, while in the second part of this presentation I will talk about the conservation treatment and the research study using two paperboard facsimiles. So the artwork that you can see in the current slide was created in 1971 and comes from the Remo Brindisi House Museum in Comacchio. From the 1960s onwards, Grignani developed the concept between the Psicoplastica series, during which this artwork was created. As the prefix "psycho" of the neologism suggests, the artist focused on the mental perception of the space. Psicoplastica is a dynamic representation in which the depicted volumes and surfaces are impossible. The use of black and white amplifies the contrast between the full and the empty, the surface and depth. Franco Grignani was born in the province of Pavia in 1908 and deceased in Milan in 1999. He was a distinguished artist, photographer, and designer. His career, developed during a period of significant cultural and technological change, reflects an extraordinary ability to combine art and science. His most renowned project is the Woolmark logo that you can see in the current slide, created in 1964. This symbol, representing a stylized ball of wool, has become a global design icon featured on over 5 billion products. Grignani's visual investigation focused on the relationship between the artwork and the viewer. His research is documented in numerous notebooks that preserve his sketches and was based on three fundamental points: the use of mathematical and geometric principles, the pursuit of a cognitive and mental effect on the viewer, and the use of perceptual tools and techniques such as autofocus in photography to achieve a specific mental result on the observer. To produce his works, the artist followed a meticulous process, which was confirmed through the observation of the case study. He began by sketching a preparatory drawing with a graphite pencil using a ruler. He then, using a pen, traced the outlines of the geometries with black ink. Next, he carefully filled in the lines with the flat black areas, leaving the white cardboard exposed where required. Finally, he applied a thin transparent layer, presumably by spray application. It is plausible that this coating was intended to provide a degree of uniformity or sheen to the surface. As you can see on the verso, there is a graphite arrow that points up, and the artist's signature, both added to orient authenticate the piece. The support is a multi-layered structure made up of 3 sheets of white paperboard, joined together with a vinyl adhesive, lined on the recto with a sheller paper, white and smooth, ideal for the artist's geometric precision, and on the verso with a gray paper. This specific type of support is known as laminated paperboard and represented Grignani's favorite choice, as it fully met the technical requirements that he needed. The surface is characterized by homogeneity and brightness and ensured a high degree of precision and an optimal contrast with the black of his filled areas. When the artwork arrived in the conservation laboratories of the Academy of Fine Arts, it showed numerous signs of deterioration, mainly due to the prolonged exposure to humidity. The multi-layered structure of the support is highly sensitive to the thermohygrometric fluctuations and had suffered significant deformations. Humidity had caused swelling of the cellulose fibers, and the subsequent phenomenon of blistering, particularly evident in the unpainted areas. This was due to the pressure generated by the sudden release of gas or water vapor. A widespread but inactive, luckily, as we can see later on in the presentation, fungal attack had compromised the support, leading to felting, discolorations, and foxing, but also pigmented stains and deposits, which are signs of the metabolic activity of the molds. Um, Furthermore, a loss of cohesions in the materials was seen. In the past, an attempt to clean the mold by abrasion had caused losses of the paint layer and dragged the pigment, black pigment, into the white paperboard preserved areas. As you can see in the picture on the left, in Rankin light, these abrasions and small scratches are visible. A crease and a delamination on the lower left corner suggested improper handling of the work while it was still humid, likely in an attempt to remove it from its original frame. On the painted surface, two types of fluorescences were visible: the white ones, which were more extensive, and the bluish ones, which were more localized. Both were the result of the migration of salts originally present in the binder or in the support, and this resulted in an opaque matte deposit that altered the intensity of the black paint and reduced its visual depth, compromising the overall legibility of the work. So a mapping of the fluorescence in the paint layer was carried out to help during the treatment. And as you can see, I removed the black lines in order to facilitate the reading and interpretation uh, of this image. The paint layer presented small lacunae caused by the blistering, silverfish activity, and mechanical action. The larger losses, though, were attributable to the aforementioned attempt at cleaning the molds by some inexpert operator. The digital mapping of the stains helped us realize that probably the verso was in contact with the humid source, since the stains were more extended. And the digital overlay of recto and verso revealed the correspondence between the stains present on both the surfaces. This correspondence, however, was not entirely direct or uniform, as we would expect from a thinner or single-layered paper support. The digital mapping of the stains helped us realize that probably the verso was in contact with the humid source, since the stains were more extended. And the digital overlay of recto and verso revealed the correspondence between the stains present on both the surfaces. This correspondence, however, was not entirely direct or uniform, as we would expect from a thinner or single-layered paper support. The Rankine light revealed the fragile areas of the artifact, as well as the planar distortions, which are more visible on the verso than on the recto because of the uh, optical effect. Histochemical tests confirm that the support is a laminated paperboard, composed of the layers which went singularly through a size press when they were created, and then later on assembled together with a PVAC adhesive, uh, which reacted to the histochemical spot test with a pinkish coloration. FTIR analysis carried out on a color sample revealed the alkyd nature of the binder. The inactive state of the fungal attack was verified through biological investigations. This began with the optical microscope observation of 3 samples, which showed, as you can see in the slide, severe degeneration of the vegetative fungal structure, and the inactivity of the fungal attack was further confirmed by the ATP and new NAG test, as well as the cultural analysis, which revealed no growth. Based on the condition report of Psicoplastica nel campo, A treatment methodology was developed with the aim of recovering the chemical physical stability of the object and re-establish the legibility and the proper experience of the artwork. Given the relatively recent date of the artwork, the conservation treatment followed an extremely cautious approach, with preliminary testing at each stage to evaluate the material's responses and to ensure the reversibility of the products used. The complex multi-layered structure of the board with more intricate hygroscopic properties than a single-layer paper sheet required particular attention. Each test made it possible to precisely calibrate the operational parameters such as timing and the product concentrations. The treatment began with the removal of the surface deposits, alternating between dry and wet methods. On the recto, coherent deposits were removed with a scalpel, while the incoherent deposits were selectively removed using different types of erasers. To avoid further damage to the weakened medium, brushes were not employed to eliminate the residues produced by the erasers. Instead, low-pressure microsuction was preferred. Where dry cleaning was insufficient, cotton swabs moistened with distilled water were used. The verso was instead dusted with a soft bristle brush, removing the powdery residues of the inactive fungal spores. Due to the heavily pigmented deposits caused by the fungal attack that were deeply anchored to the fibers, an 8% PBA borax gel with 1% gel and gum was applied by dabbing, followed by a delicate dry cleaning of the surface. Removal of the white and bluish efflorescences on the film layer was tested with various methods illustrated in the current slide. Double distilled water applied with swabs effectively removed the white efflorescences, but not the opalescent bluish ones, which were reappearing after evaporation of the solvent. So, to treat the areas with the bluish efflorescences, swabs soaked in 1% and 2% triammonium citrate solutions proved more effective. The 2% solution was preferred for its faster action. Deeper efflorescence anchored within the fibers were not removed to avoid damage to the film layer. Finally, chelated residues were washed out by rinsing with the swab and water at pH 8. Stains and foxing caused by the microbiological attacks were treated to even out the appearance of the support and re-establish the contrast with the black uh, paint. An initial test with 1% TBAB solution in water did not yield satisfying results, so a selective application of sodium borohydride in deionized water is then chosen to reduce the discolorations. The foxing was attenuated with the same reducing agent and then subsequently removed mechanically with a scalpel by gently scraping the surface and making sure to preserve the texture of the support, also using Rankine light. At this stage, consolidation was carried out using a 2% funerary solution in water, applied uniformly on the recto with a Japanese brush through a sheet of Japanese paper. The consolidant reinforced both the paint film and the support and produced a slight cleaning effect. At this point, the lamination revealed with the rise of the moisture content in the support, and they were promptly recompacted. For the flattening, it was necessary to identify a method to recover the planarity. An experimental study was carried out on two mock-ups of a Scheller laminated board sourced from the market that faithfully reproduced the structure of the original object. The main objectives were threefold: to understand the delamination mechanisms observed on the case study, to evaluate the effectiveness on traditional pressure-based techniques, and to develop an alternative and less invasive method. Similes were subjected to induced deformations using both direct and indirect techniques. It emerged that direct wetting combined with a slowing of the drying process by introducing a plexiglass support on the verso accentuated the material's internal stresses. Furthermore, a vertical positioning highlighted the role of gravity in promoting more pronounced distortions. The results of the deformation methods tested led to the conclusion that the deformation of the object under study was most likely starting while it was still mounted in its original frame and positioned vertically. Traditional flattening methodologies rely on applying pressure. The humidified object is placed between absorbent materials and pressed with weights or presses to facilitate moisture transfer and interfiber reorganization. To investigate, we ran two trials on facsimiles under loads of 60 and 65 kilograms. We noticed that on multi-ply paperboards, which are thick, composite, and carry production-induced anisotropies, this approach shows significant limitations. Drying times and the weight applied are not always measurable, and full face contact becomes risky for fragile paint layers. Furthermore, the access to the object while drying under pressure is not possible. For these reasons, we adopted a perimeter restraint technique already used for thin paper objects and photographs. After humidifying the support, we applied wooden buttons along the edges, overlapping by a few millimeters and clamping to a rigid permeable plywood board on which the object was positioned, interposing remade to avoid direct contact with the wood and leaving the center free to ventilate. On multi-ply boards, this restraint prevents lateral shrinkage and transmits the tension through the adhesive bonds so that the assembly behaves mechanically as a single sheet. Finally, we monitored drying and adjusted peripheral tension as needed. When properly adapted to the characteristics of multi-ply paperboards, the perimeter restraint methodology proved to be a safe, controllable, and effective alternative to weight-based protocols, particularly useful for sensitive surfaces and large formats. The tests carried out on the facsimiles demonstrated that by reworking a traditional lateral restraint method through diagnostics and controlled tests, some established techniques, when critically revisited and readapted, become a powerful source for new, less invasive conservation strategies that can recover flatness. The study's results made it possible to successfully apply the identified method to Psicoplastica nel campo 400, as you can see in the next slide. For losses in the paint film, a retouching color was prepared using vine black pigment mixed with the consolidation solution of 2% phenolic. A superficial layer of wheat starch paste helped us to achieve the degree of gloss of the original color. Lightly undertone infills were executed, distinguishable only at a close range. On the verso, retouching was carried out with colored pencil to improve the visual continuity of the surface. I will conclude by discussing the important mounting phase, which represented both a conservation and a technical challenge. Mounting an artwork is not merely an aesthetic concern. It must meet several fundamental requirements, such as protection, functionality, and respect for the original intent. In the case of Psicoplastica nel campo 400, the original mounting proved inadequate for ensuring long-term protection, exposing the work to the agents of degradation that made the treatment necessary. To arrive at the adopted conservation solution, it was necessary to reconstruct the stages of the original mounting system. Archival research and a comparison with the other Grignani works was carried out and highlighted the uniformity of the mounting structure used, designed by the gallerist Nino Soldano. Works from that period were mounted on a wooden frame, often bearing identifying inscriptions and stems, with a masonite panel protecting the verso and a glass in direct contact with the recto. Direct observation of these works revealed the conservation limits of that system, showing how direct contact between materials contributed to the object's degradation. Hence, the need for an innovative approach that would respect the original intent while improving protection and conservation. The new conservation proposal, therefore, replaced the masonite with a more stable plywood panel and introduced spacers of conservation-grade board between the work and the anti-reflective and anti-UV glass to eliminate the risk of direct contact. A significant change from the original mounting was the decision not to reproduce the circular window that exposed the signature. Instead, a photograph of the signature was placed on the back, aligned to the original position, in order to provide great protection without compromising the authenticity. The following slides show the object before and after conservation treatment and after mounting. After treatment, the work was returned to the Remo Brindisi House Museum, where it's currently on display. Thank you for following, and if you have any questions, please do not hesitate to contact us.